Hey, welcome to The Explainer. Today, we're going to do something pretty cool. We're making the invisible visible. We're diving deep into those huge, crazy complex computer networks that run our entire digital world. The big question is, how do you even begin to map something that's always changing?
Okay, picture this. What if you tried to get around your city, but there were no maps, no street signs? And to make it even crazier, what if the roads themselves just changed every single day? It would be total chaos, right? You'd be completely lost.
Well, believe it or not, that chaotic, mapless city, that's pretty much what it's like for the folks who manage the massive, invisible networks we all rely on. I'm talking about the digital highways that bring us everything from our Netflix shows to our online banking. It's their reality. So, what if you could finally give those engineers a map for that maze? Well, that's exactly what we're digging into today. There's this tool, it's called the NetOpsVA Route Map Viewer, and its whole job is to bring some serious order to that chaos.
So what is this thing really? Let's break it down. In the simplest terms, the Route Map Viewer is a tool that creates a live visual map of the entire network. We're talking complete picture of how every single device is hooked up and all the different data highways, the routes that connect everything.
Let's go back to our city analogy for a sec. Think of this tool as your GPS, the city planner's master blueprint, and a live traffic map, all rolled into one incredible package. It's showing you where everything is, how it's supposed to connect, and what's actually happening on those digital roads, right this second.
Okay, that sounds awesome, right? But how? How does it actually build such a detailed map of something you literally can't see? Let's get into how this map is actually made. You can think of this tool as a kind of digital cartographer, a map maker for the internet. But here's the cool part. Instead of sending out teams with survey equipment, it builds the map automatically and really intelligently in just a few key steps.
So here's the process. Step 1 is device collection. The tool goes out and connects to all the network gear, the routers, the switches, and basically asks, hey, who are you and who do you talk to? Then comes step 2, node creation. It takes all that info and starts placing everything on the map, kind of like putting buildings and intersections on a city grid. After that, step 3, link creation. This is where it draws the roads connecting all those points. And finally, step 4 is neighbor discovery. It figures out and maps all the on-ramps and off-ramps that connect this network to the rest of the internet.
Now, the fancy technical term for this whole thing is a node link topology, but don't let the jargon scare you. It's just a formal way of saying it creates a map of dots. Those are the nodes, and the lines connecting them. Those are the links. The bottom line is, engineers can finally see how everything is actually wired together.
All right, let's look at the building blocks of this map. You've got two main things. First, you have nodes. A node is basically a place on the map. It could be a specific device, like a router, or it could be a whole network, like a digital neighborhood. Then you have the links. These are the roads connecting all the places. And these links have important details, like the protocol, which is kind of like the type of road. Is it a superhighway or a local street? And the interface, which is the exact on-ramp you're using to get on that road.
Okay, so we get it. We have this super detailed, automatically generated map. That's cool from a tech perspective, for sure. But why does it really matter? What's the so what? Why should anyone care?
Yeah, this is way more than just a pretty picture to show in a meeting. This map has real-world consequences. We're talking about saving tons of time, preventing those awful, catastrophic outages, and keeping all the services you rely on every single day, from your work email to your favorite video game, running smoothly just like they're supposed to.
So let's tick off the big benefits for an organization. First, improved network visibility. Engineers can finally see the whole city instead of just guessing what's around the next corner. That directly leads to faster troubleshooting. When something breaks, it's like spotting an accident on a live traffic map. You can find it in seconds instead of hours. It also allows for proactive monitoring. You can see a digital traffic jam starting to form and fix it before it grinds everything to a halt. And get this, automated documentation. That map is always live, always up to date. No more old, useless diagrams. And here's what makes this map so incredibly powerful. It's intelligence. It understands all the different rules of the road on the internet. We're talking about all the different routing protocols, things like OSPF, BGP, you name it. It doesn't matter how complicated the traffic laws are in one digital neighborhood versus another, this tool can read all the signs perfectly and give you a complete, accurate picture.
So really, it all boils down to this. When you can finally visualize all these insanely complex relationships, your network teams can slash that expensive downtime and just get way more done. It's all about working smarter, not harder, and being proactive instead of reactive.
So we can now create these incredible maps of our digital cities. It really makes you wonder, doesn't it? What other huge, invisible systems that run our world are just out there, waiting for someone to finally make them visible?